second derivative is positive, it's going to be concave up, which means it's going to be opening upward. And here's where things run kind of counterintuitive. If the second derivative is positive, you don't have a maximum. What do you have? A minimum. Folks will often see, aha, it's positive, and automatically go from positive to maximum. But remember, the positive is talking about the shape of the curve. It's going to look like a smile. And with a smile, you get a minimum. We also talking about with second derivatives that if the second derivative is less than 0, it's concave down, which means it's going to open downward, and the negative result is going to be what gives you a maximum. So be careful not to get those backwards. It's real easy to do, and I understand that it can be real easy to get them mixed up one way or the other. Okay? But there's what's going on. Be careful with that. Now, with Chapter 2, it's going to talk about exponential and logarithmic functions. Very honestly, I want to get to Chapter 3. Chapter 2 is a whole lot of rerun, so we're going to zoom through Chapter 2 fairly quickly. Okay? In Chapter 2, okay, in Section 1, what we're going to talk about here are exponential and logarithmic functions. We've already talked about exponential functions. One of the places where exponential functions are going to come into play is in computing interest. In the business world and in your own saving, interest is really important. It should be of interest to you. Okay? Because that's what's going to allow your retirement account to build to the point that someday you can retire and actually still eat. And go on some cool vacations, hopefully. Or do whatever it is you want to do. Okay? May not have enough money to buy a Koenigsegg. What's that? One of you is smiling. My son and I were looking just for grins over the weekend. It's a car, custom made. I mean custom made all the way. Brand new, you can buy a base model, an introduction to, and these are a sharp car. They are a killer car. Okay? You can buy them for as cheap as $3.5 million. Now, if you want the really nice finished off high-end one, well, it's going to cost you a little bit more. It's going to cost you about $7.5 million. You may not have enough money to buy one of these puppies, okay? But you can buy a nice car. Okay? What we're going to look at is, first off, one of the basic formulas for computing principal. And one of the basic formulas is P of T. The principal is the amount of money you have, equals P sub 0. What's P sub 0 going to indicate? The amount at the start, that's how much you put in to begin with, times 1 plus r over n raised to the n t. Okay, well, that's all well and good, but what's this stuff mean? R is the interest rate. Now be careful, because it's going to be the interest rate not as a percentage but as a decimal. Okay, it'll be the interest rate as a decimal. So if you're getting 8% as a decimal, that's going to be 0.08. Does that make sense to everybody? Okay, so the interest rate is going to be as a decimal. T is going to be the time in years. N is going to be the number of times per year that interest is compounded. And we've already talked about P sub 0. P sub 0 is the amount to start. Okay. I suspect that most of you have heard about the 7 wonders of the world, things like the first off, cut as perfectly as they were, and secondly, how do you lift them up as high as they got them? Okay? People still wonder about some of these things. Einstein called compound interest the eighth wonder of the world. What compound interest does is, okay, let's say Kyle takes some money and he invests it in an account that Nick's running. Nick has an investment firm. It's okay to get pulled in on this, Nick? Okay? Nick's going to be a financial advisor. And what happens is, Kyle gives him some money. Let's say he gives him $1,000. And what happens is, the interest doesn't get paid once a year. That's called simple interest. Oftentimes it'll get paid quarterly, monthly, or what is termed continuously. That means every second you get paid more interest based on what the amount of money you had a second ago. Let's go back to something like monthly. Let's say this is at 12%. Nick's got some mutual funds going that are paying really well, 12%. So that works out to be basically 1% a month. So what happens is, if Kyle puts his money in January, in February, he still has these $1,000, plus he has interest on the $1,000. Well, the interest is going to be the 0.12 divided by 12. Why are we dividing by 12? 12 months in a year, and it's only been there 1 month. Okay? And what this is going to work out to be is $100 in interest. So at the end of February, Kyle now has $1,100 in his account. Now, in March, the amount of money that's been invested is not $1,000, it's $1,100 that's been invested, isn't it? And the interest that is going to be accumulated from that is not $100, but $110. $10 of that is money earned on the interest from the previous month. Do you see that? So what he's getting is interest on the interest. Which means that at the end of March, he now has $1,210. April, when Nick invests it, there's $1,210 there. And by the end of the month, he's now gotten another 1%, so he's gotten $121. So by April, Kyle has gotten money, has gotten interest from February and from March, hasn't he? And the interest he got in February has had interest put on it twice now. This is called compound interest because it keeps building on itself. Okay? Does that make sense to everybody? Doing interest like this really does some amazing things over a period of time. The key is time. It takes like 25, 30 years for it to really kick in. But it gets really crazy. Okay, so now that you kind of understand how compound interest works, this formula can be used in several different ways. One, we could use this formula where n is going to represent monthly compounding. If it's monthly, n is going to be 12. If it's quarterly, quarterly is Latin from quart, Q-U-A-R-T, and what does quart mean? 4. If you can't remember that, how many quarters are there in a dollar? Most people know there are 4 quarters in a dollar. That's where the word for quarter comes from, is 4 in a dollar. So if it's compounded quarterly, n is going to be 4. If it's compounded semi-annually, that means it's going to happen twice a year, so n would be 2. And if it's compounded annually, annual means yearly, n would be 1. Does that make sense how to use that? What you can also do here is a little bit of mathematical razzle-dazzle. And what we're going to do for that is we're going to let a new variable m equal n over r, which means n is going to be equal to m times r. I say, well, okay, that doesn't make a whole lot of sense. I'm not sure why I'd want to do that, but let's do that anyway and see what happens. What that allows us to do then is to rewrite P of t as P sub 0 times 1 plus r over, now in place of n, we're going to put m over r, and in place of n, we're going to put m times r times t. Everybody okay? This cleans up a little bit to give us P sub 0 times 1 plus 1 over m to the m r t. Is everybody good? Okay, pretty straightforward algebra so far. Here's where we start playing a little bit with the calculus. M is going to be something we're going to let go to infinity. Well, why are we going to let it go to infinity? What we're going to do is we're going to play the game where you get interest every second, every tenth of a second, every hundredth of a second. If you keep doing that, more so and more so, how many times a year are you going to get interest? It's going to be continuous, isn't it? So Nick's there constantly refiguring Kyle's interest, and he just spends his whole day doing Kyle's interest. Well, not so much. What you do instead is you say, okay, if we're going to let m get bigger and bigger and bigger, we're just going to say, hey, it's going to go to infinity. We're going to have this function that we developed. And we're going to pick out some of this because some of this doesn't necessarily have anything to do with m. Like the P sub 0, is that going to change any? Is the initial amount that Kyle brought in going to change? Well, it's going to grow, but the initial amount is always going to be whatever that amount was, isn't it? So what we can do is we can pull the P sub 0 out front using some of the basic properties of limits that we talked about earlier, as in earlier in the semester. 1 plus 1 over m to the m. Now, what I'm going to do here, say this is to the RT. I'm just going to split apart the exponents. Okay, all I'm doing is splitting them apart there a little bit. And this part right here, you may or you may not recognize this. It's often written as the limit as n goes to infinity of 1 plus 1 over n raised to the nth power. Okay, so it's often written like that. Does anybody recognize what that's equal to? That's E. That's what E is defined as. You know that number E? Okay, this is E. Huh, interesting. Okay, so what's that get us? What we now have is P sub 0. This whole deal here can be replaced with E, and it's still raised to the RT. Has anybody ever seen that formula before? Pert? This is for exponential growth. We use it for growth and decay, things like radioactive materials and all kinds of good stuff like that. We use it for logistic growth curves as we get closer to section 2.5 or 2.6. Okay? But this formula, as it sits there right now, is a way to compute continuous compounding. Okay, so this formula right here is for continuous compounding. Okay, so what's this have to do with anything? Well, let's talk about how this could be useful toward retirement. And I try to throw something like this in on every single class I teach because I don't want anybody to get 35 years down the road and come back and say, Chuck, I wish you would have told me. I wouldn't be eating cat food now. Oh, cat food's too expensive. I wouldn't be eating dog food now if you would have told me this. Okay? When you get a job, a career job, or if you have a job now where you can put some money into retirement, if you've got enough money, that means you don't have to take out student loans. The first thing now is to avoid student loans. Avoid them like the plague. Okay? Student loans are a very bad thing. They've actually superseded credit cards now as the #1 source of debt in the United States. Okay? And people say, well, it's cool, I'll pay it off later, and I'll use the money now to go to La Rosa's. You have a guy in another class right now. He got his student financial aid money back in September, went out and spent it all. Apparently had a good time. And he said, now I gotta get a job because I need that money. Okay? So don't go taking money to go to La Rosa's and whatever else it is you want to do. But when you get a job, or if you have the money now to do so, and have a job where you can put into a 401k, what's a 401k? It's a way to save for retirement. Where'd they get that name? It's the part of the tax law, the section number of the tax law that establishes this method. Okay, so section 401, article K, is what establishes this thing for folks to be able to save in. Which is you have money put in there every month if you can afford it now, especially if your employer provides matching funds. What does matching funds mean? What's matching funds? Any ideas? That means if Chuck puts in $50 up to a certain percentage, guess what the employer will put in? $50. Do I have to do any extra work for it? Nope. Do I get taxed on it? Nope. When was the last time you were offered money that wasn't taxed and you didn't have to work for? Other than when Grandma came up and said, honey, you look hungry. Okay? This is a way to actually get tax-free money without doing any extra work. It's part of the benefits. Anyhow, so Kyle remembers this, gets himself a good job. Between his contributions and what his employer puts in, let's say you put in $800 a month. $700 bucks. Let's make it $700 a month. It's $700 a month. And if you do this before you even get your first paycheck, is your paycheck going to go down by $700? No. It'll go down by $500. Or even less if your employer's matching, maybe $400. Well, why does it only go down by $400, Chuck? There's something wrong with the math. This money comes out before there are any taxes. That means you're not paying taxes on. If you would have gotten that money in your paycheck, would you have gotten $700 bucks? No, they take 30 to 40% of it in taxes before you ever see it. You've seen that on paychecks, haven't you? There's the amount over here, then there's the amount here that you get, and all kinds of money disappears along the way. Is there any way to control how much money disappears along the way? Yes, it depends on who you vote for. If they're offering free stuff, who's paying for that free stuff? Well, I assume they are, aren't they? No, that comes out of your pocket. It's called taxes. The first moment they say, we're going to give free blah, 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 they're waving this hand saying free, and with this hand they're getting the money from your wallet. It's not free. That means raising taxes. Okay? So anyway, your paycheck only goes down by maybe $450. And if you do it from the very start, you never miss the money because you've never had to begin with. You just learn to live on it. Yeah, but what's that going to do? Well, at the end of the year, that's $8,400. Okay? So by the end of the year, Kyle has given Nick $8,400 of his money. And Nick is working hard to make sure that money grows, because that's the way Nick gets paid. If Nick doesn't do a good job, Kyle's going to take his money and go elsewhere, isn't he? That happens to too many people. Nick's getting hungry. Okay? The way you compute how much this $8,400 is going to be worth by the time Kyle retires is by using this formula. Let's see what happens in 35 years. We've got the $8,400 E. Now, I'm going to pitch this kind of conservatively. If you look at it over the last 50, 60 years, 80 years, long and near, the stock market's returning right around 10%. But let's do 9% times 35 years. Over that period of time, I know some years the stock market goes down and some years it goes crazy, but it averages out to about 9-10%. So let's see here. 8,400 times E raised to the 0.09 times 35, boom, equals. Whoa, that's interesting. $19,000, right? Is that what you got? $19,600? No, what'd you get? That's right, $196,000. That's just from the money that Kyle put in his first year. The second year, if he continues at the same pace and puts in $8,400, e to the 0.09, this time it's going to be times 34. Why not 35? Yeah, he's a year closer to retiring. So now we do it the 34th. Well, it's not quite as much money. $179,151. Now, something I want you to notice here. This is 2 years that Kyle has put money into retirement. How much money is going to be there about when he retires, just off of those 2 years? $375,000. Well, if he keeps this up all 35 years, how much is going to be there by the time he retires? Enough to live on. Okay? So let's say by the time he retires, and remember each year it's worth less in the end because it's had less years to accumulate. Let's say it works out to be $3,200,000. Okay? So that's what Kyle has in his retirement fund 35 years later. Figure you can live on that? The cool thing is you have it shifted. Rule number 1, you never, ever, ever, never take this money out as a check, because the government will come back and they'll tax you to the tune of 40 or 50%. They'll take half of all your money away in the form of taxes. What you do is you have Nick move it from one thing to another. When you hit retirement, okay, this is going to be shifted to something a little bit less volatile. It's not going to go up and down as much, and let's say you're only making 6% on it. Okay? This means that every year, Kyle is going to get a check for $192,000. That's just the interest. Kyle, could you live on $192,000 a year? Okay, it'd take a little bit of change in your standard of living, right? Okay. But the cool thing is, even after he spent $192,000, how much is still in his account? $3.2 million. And the next year, what's he going to get? Another $192,000. And what if you don't spend it all? Well, you leave it in the account. And then the problem is the next year you get $195,000, right? Because you got more in this account. So you're going to get more interest. And it just grows and grows and grows. And you can actually live. Don't be one of those people who gets to retirement age and says, oh, I hope Social Security's going to be there. Oh, good, I get $450 a month. Can you live on $450 a month? No way. Here is how get your career type job, walk into HR and say, I need to set up my retirement account, and get it done right then and there before you even see a check, and things are all good. Now, actually, this is a loser scenario. This is Kyle if Kyle is a real loser. Doesn't look like a loser to me, Chuck. $3 million? That's no loser in my estimate. How are you calling Kyle a loser? It's $8,400. We're just assuming $8,400 a year, aren't we? This means Kyle works there for 35 years and he never gets a raise. Sounds like a loser to me. Would you work somewhere for 35 years and never get a raise? Okay? So it's actually going to be better than this, isn't it? Because as you get raises, you can take and contribute more, not all of it obviously, but some of it, for retirement. Do you have to work till a certain age to retire? Do you have to work till you're 65? Actually, they're pushing it up to 68. Do you have to work till 68? Or by the time you retire, it'll probably be 70 something. Do you have to work that long to retire? Is there a law that says you have to work to some age? Bill Gates, is he retired? Well, he's busy doing stuff. Yeah, but does he go to Microsoft every day? No, he's retired. He's doing what he and his wife want to do. They're giving their money away. That's what most millionaires do. They give it away. Yeah, but they keep some for them. True, they do keep some for themselves. They earned it. But the bulk of it they give away. Okay? Does this make sense on how to use this formula? Where this formula comes from? Where E comes from? The definition of E? The cool thing is, if we take that 1 plus 1 over n, parentheses n, and you put it in your calculator into y1, then we go to the table. As you put in bigger and bigger numbers for n, you get the 2.7 number that comes out as being the value of E. That's where the value for E comes from. Is that? Yeah, Chelsea?
For the $8,400, is that like the initial $8,400, or is that what he's putting in every year? Like, is he putting
$8,400 is over the course of a year. Every month he puts in $700.
Okay.
$700. So over the course of the first year, he's put in $8,400.
So then does he put in an additional $8,400 every year? Or
Yeah.
is that the same one?
Every month, you have more, or if you get paid every 2 weeks, every 2 weeks you're putting in more money. And to make life a little bit easier, and in fact, next semester when we get into integration, I'll show you paycheck by paycheck how you figure out how much this is going to be. But that's a whole lot of adding. This is just a quicker, shorter way to do it. Okay? Is this exactly accurate? No, but it's not bad. Next semester you'll get to see the way it's really figured out. This is more of an estimate. But, you know, if Kyle gets to retirement and 3.2 million, 3.4 million, does it really make that much difference to you, Kyle? What's a couple $100,000 to Kyle at this point? That's chump change, isn't it? Okay? My wife's parents did this. They've got a problem. Okay? Dad said he was going to retire, and I said, you guys going to be okay? Because if you aren't, we'll help you out, because that's what kids do. They help their parents. Okay? And he smiled. He said, I think we'll be okay. About a year later, I checked with him. I said, are you guys doing okay? Do you need any help? And he said, Chuck, we do have a problem. I said, we'll help you. What's your problem? He said, the money's coming in so fast we can't possibly spend it. Dead serious. You know what a vacation looks like to them? Dead serious. After Christmas and New Year's Eve, they go down to Florida, they rent a house, and they stay there for 3 or 4 months at a time, charter a boat, rent a fishing guide, and they go fishing every day for 3 or 4 months. And that's their winter vacation. Long about Easter, they come back up. Take a few vacations over the summer. And the money's coming in so fast they can't spend it. Wow, that's a rough way to live. Okay, that's how I want you to find yourself. All right. There are several things you need to be aware of also in section 2.1. Okay? One of those is when we have these exponential functions, you need to know how to solve these things. If you have things like e to the 1/2 x equals, let's say, 45. If you're asked to solve for x, notice this is all algebra at this point, isn't it? This whole thing has been algebra. How would you solve for x there? Well, the catch now is the 1/2 x isn't times anything else. It's up in the exponent, isn't it? That's why e is called an exponential function, because the variable's up in the exponent. Okay? Well, the first thing you need to do is you need to apply the inverse of e. And what's the inverse of e? Natural log. Way to go. And if you apply natural log to one side, you have to apply it to the other side as well. And whatever might be on the other side, the whole other side in one gulp gets zapped with natural log. In this case, the whole other side is just 45. The natural log and the e will cancel, giving you on the left side 1/2 x equals the natural log of 45, where x is equal to 2 times the natural log of 45. Is that something you can do on your calculator? Sure is. You just poke natural log 45 in, enter, times 2, bing, you've got x. It's just that easy. Does that make sense to everybody? Are you okay solving stuff with e in it? Okay. Another thing that you're going to wind up needing to be able to do is, let's say, if something like this, the natural log of x plus the natural log of x plus 2 equals, let's say 2. Ooh, that looks ugly. That looks really bad, Chuck. Okay? On page, what is it, 199, right along in there in your book? Yeah, on page 199, there are a bunch of properties for natural logs. Okay? I'm not going to spend time on them because you are all quite capable of finding this little gray box on page 199. There are 8 of them. Know them. Okay? Know them. When you look at it, it's going to be, oh, yeah, hopefully. Okay? One of those properties, the very first one, says that if you have two things being added together, that can be rewritten as the natural log of the first thing times the second thing. And it's still going to be equal to 2, and I'm intentionally writing the 2 over to the side a little bit, saving some space there. Okay, now how do you undo natural log? What's the inverse of natural log? It's applying e to each side, isn't it? Okay, so we're going to do an e here, and we're going to do an e here, and notice everything winds up in the exponent. Everything in the left-hand side goes into the exponent area on that e function. Everything on the right-hand side, as one chunk, goes into the exponent. These will cancel. And what this gives you is x squared plus 2x. Where'd the x squared plus 2x come from? Distributing, right? Back in the good old days. Minus e squared equals 0. Oh my gosh, how am I going to solve that? What's the e squared doing over there on the left side? You need a number there. E squared is a number. It's around 8. Not exactly 8, but something around there. And that's quadratic, isn't it? How do you solve quadratics? With the quadratic formula. And on this, a is equal to 1, b is equal to 2, and c is equal to negative e squared. Plug them into the quadratic formula and let it fly. If you don't have it on your calculator, run down to the math lab and say, I need the quadratic formula put into this thing. And they'll stick it in real quick for you. Okay, and it goes in as a program, so you just press the third button down, third button over, program, and you'll see quadratic formula or quad form or something like that. You press it and it's going to say A equals, you plug in 1, press enter. B equals, you press 2, press enter. C equals, you put negative e raised to the 2, enter, and it spits out the answers just that fast. Okay? Well, what if I don't get it in? Well, you can always do it other ways, like set this equal to y1 and graph it. And when you graph it, I don't know exactly what this is going to look like. I'm just making something up here. But it'll graph something like that, and what you then need to do is to compute these two roots using your calculator. Personally, I'd rather go to the math lab and have them put the quadratic formula in. It's your call. Okay. All right. Does that make sense for that? That's basically section 2.1. On section 2.2, and I've got 2.1, 2.2, 2.3, 2.4 homework all plugged in, and you've got till November 29th. But I would suggest that you get it done well before November 29th. Okay? Because test 2 will be well before November 29th. Okay? That's a good way to get ready for the test. 2.2, real easy. It's the derivative of e to the x. Oh, wow. What's the derivative of e to the x? We've already talked about this, haven't we? What's the derivative of e to the x? Right, e to the x. Remember the other day where we did the Taylor series expansion? I showed you it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and said that's going to be on some test somewhere, like making an appearance on test 2. Okay, well, with that, what if you have something like y equals e to the negative x squared plus 7x minus 4? And you need to compute the derivative because you want to find a max or a min point. Max or min points occur where the derivative is 0. The way you would do the derivative of this is to first figure out which rule is this. A lot of people are tempted to say product rule because it's e times that minus x squared stuff. It's not e times, it isn't. It's e applied to. So it's like saying the square root of that quadratic mess. So this isn't a product rule, it's a, begins with C, H, A, chain rule, there we go. This is a chain rule. And the way the chain rule works for this is you take the derivative of the outside and you leave the inside alone. What's the derivative of the outside? Well, the derivative of e is going to be e. You leave the inside alone. There's part of it. Then, after you've got the outside done, leaving the inside alone, then you come back and you take the derivative of the inside. The derivative of the inside is going to be a minus 2x plus 7. And that's it. Walk away from it. Don't try and do anything to it. You'll just break it. Okay? Don't mess with it. Let's say if something like this. Y equals e square root 7x minus 5. And you have to take the derivative of that. Ooh, that doesn't look good, Chuck. Okay, well, let's rewrite this a little bit first. This is the same thing as e raised to the 7x minus 5 to the, because it's a square root, the 1/2 power. The derivative, part of the answer is going to be, well, when you take the derivative of e, what do you get? E. So we're going to get back this e, and the stuff inside of it is unchanged. Does that make sense? That's part of it. It's not all of it, but it's part of it. Now, what we need to do is take the derivative of what's in the exponent. To take the derivative of what's in the exponent, it's going to be a chain rule itself, isn't it? Okay? So what we're going to do is we're going to, and this may help you to see what's going on, we're going to drag this off to the side and do the derivative by itself. The derivative is going to be 1/2 7x minus 5 to the negative 1/2 times the derivative of the inside. And what's the derivative of the inside? 7. You can take the 1/2 times the 7, and that's going to give you 7/2 times this 7x minus 5 to the negative 1/2. And there's the derivative. All that stuff together is the derivative of that function. Does that make sense? Okay, so you've got enough information to tackle section 2.1, and in 2.2's homework, the first part of it's doing derivatives of these things. You got enough information to start chipping away on those. If you did not pick up your test earlier, the tests are up here. No, the tests are over here. And remember, the corrections are due when? Friday. You're allowed to use your notes or your book. You may not use the math lab. They've got to be on a separate paper. No partial credit. You got to correct how many problems? You can do 3, or each part, like part A, part B, or part C counts as one part. You can do 3 parts. They got to be in numeric order. If you want a blank copy of the test, there are blank copies. Folks, it's good to see you. I'll look forward to seeing you all on Wednesday.